Good morning, Fairy. Welcome back to Science Time. So we're in the run up to Easter and I have some more excellent science tasks for you to do. So this one, we are basically going to make an unbreakable-ish egg. Now, if you think about it, if I just had a normal egg and I dropped it, it would make a really awful mess, wouldn't it? And I wish I hadn't. However, with a little bit of chemistry help, we can make an egg almost unbreakable. So unbreakable-ish. So we only need a few items. We need a raw or uncooked egg. We need a glass container, bigger than the egg. I've got one with a lid just so that I can seal it up just because vinegar smells a bit. But you could just use a glass. So I've put a glass on the side because that would be absolutely perfect. And you need some vinegar. Now I've got a really big bottle because I have lots of things planned over the next few weeks that need vinegar. So I thought I'd buy a really big bottle, but you don't need that much at all. We just need enough just to cover the egg when it's in the container. So that's all we need. Vinegar, a container and a raw egg. Okay, let's get ourselves prepared. Okay, so we said this one doesn't need an awful lot, but what it does need is time. So we're going to pop the egg, remember it's a raw egg, into the container. You could put yours into a glass, but I'm going to put mine into this glass jar. So place it in there really carefully because you don't want it to break. And then we're going to cover that egg in vinegar. So we're going to pour enough vinegar into the container to completely cover the egg. I'm going to pop a little bit more into there and then we're going to close up the egg and we're going to leave it for at least 24 hours. Now I'm going to leave mine for 36 just to make sure. And that's all you need to do. So I'll leave the eggs there. I won't touch them, I won't poke them, I won't do anything with them, but I'll leave them there. And in 36 hours, you'll see our unbreakable-ish egg. Okay, so while we're waiting for the eggs, what we're going to do is just a little bit of a trick. Now, this is one that comes with a great big safety warning. Please do not do this without an adult to support you, or in fact you don't even really need to do it at all. You can just watch this demonstration. So you can see if I pop the egg onto the top of the bottle, you can see that that egg is not going to go into that bottle even if I push it really hard, but with a little bit of magic it will. So the first thing I'm going to do is I'm just going to light this piece of paper. That's why you would need an adult to help you with this one or to do it for you. So I'm just going to light the paper and I'm going to pop this piece of paper straight into the bottle. So I'm just going to get a few flames coming out of it first. And then I'm going to pop it into the bottle and I'm going to put the egg onto the top. Now watch it really carefully. The egg has gone into the bottle. I hope you enjoyed that. So how did it happen? Well, the burning piece of paper went into the bottle and it heated the molecules of air that were inside and it caused them to move away from each other. Some of the molecules even escaped at the beginning. Did you remember seeing the egg kind of wobbled or wiggled a little bit? So when the flame went out and the air molecules inside the bottle cooled down, it made them kind of move closer together. And it created a vacuum, a partial vacuum. The pressure of the air outside then was greater and it actually pushed the egg inside the bottle. You probably heard the little pop as it went inside. Now I have seen before the whole egg going inside the bottle, but things don't always go according to plan when you're filming. But I hope you enjoyed that. In a few more hours we'll have a look at the eggs that are still in the jar just behind in the vinegar. See you later, guys. So back to the eggs. I hope you've been observing them over the last couple of days. You should have seen lots of bubbles onto the eggshell. And you can see these ones I've left now for the 36 hours. In fact, it's just a little over. But you can see lots of the eggshell is now dissolved. So we're now ready for the next stage. Okay, this bit might be a little bit messy. I'm going to really gently remove one of the eggs and I'm going to gently, and I really do emphasize the gently part, I'm going to gently remove or rub away the remainder of the shell. So I'm just really carefully taking it off. You can see I'm being ever so gentle, because if I'm not, what's going to happen? Yep, I'm going to have raw egg everywhere, and that's going to be really, really messy. But if I do that, you can see that it's now translucent. We'll have a closer look in a minute. I'm going to rinse it under some water, again, really, really gently, because if the tap's on too hard, it will pierce through, because this is the membrane of the egg. So you can see that shell's going. Can you see the translucent part? If you can't, you will in a minute when I rinse it off in the water. Okay, I'll be back. Okay, it's all rinsed off. Look at this. How amazing is that? There's the inside of an egg. Now, the light and the film probably aren't doing it justice, but if you have a torch, you'll be able to see the yolk inside the membrane. That is just amazing. Now you have to be really, really gentle with this part, but if you already feel it, you can see as I hold it up, you can see the bounce. There's the bounce factor. So in this experiment, you've turned a raw egg into a bouncy egg, but we still have to be really, really gentle. We'll have a little go at bouncing it in just a moment. Ready? How cool is that? It's bouncing. But you have to be really careful. You don't want to over bounce it, because the membrane is still quite weak and it will break and you'll end up with egg all over the table. But if you're gentle with it, it works just like a bouncy ball. So how does it work? Well, the vinegar, if we go back to where we were with the other stage, the vinegar is a safe but weak acid, and the shell is made of calcium carbonate. Now, when the two came together in the jar, there was a chemical reaction. The acid, or the vinegar, broke down the calcium carbonate of the shell and produced CO2, or carbon dioxide. That's why you can see there's still some bubbles on the shell. So that's the carbon dioxide. After 36 hours, the shell was nearly all dissolved. So you could just rub away the rest of it that was left, and you're left with this rubbery, translucent egg membrane. And the membrane is tough. That's why we can bounce it. It's also semi-permeable, so you can explore osmosis. Now that's kind of wyvern stuff. You don't need to worry about it. But some of you might want to look it up, so you might want to do an extension. Now if you're careful and don't break the membrane that you've got here, the bouncy membrane, you can explore osmosis. So you can see that this membrane is semi-permeable. You might want to put it in some golden syrup and see what happens. You can fill a little container, maybe one like this, with some golden syrup. Pop your egg membrane really carefully inside the golden syrup and see what happens. Let me know, post it on the blog, see how you get on. I hope you've enjoyed our second instalment of an Easter week science time. See you later, guys. Happy exploring.